So for this last one, is it just it's undefined at 0, 0? For number 6?
Well, 0 for y can't happen because it's not in the domain of the original function, right?
Yeah, exactly. So it's also critical
But
points
it's not undefined. The function's not undefined at x equals 0, right?
Yeah, it is.
No, it isn't. Square root of 0 is 0. The function is not undefined.
0, 0, it's undefined.
True, but that doesn't answer what's the critical points.
Yeah, it is, because under critical points includes where it's undefined.
No. Look here. Critical points included where the derivative is undefined. If the original function is undefined, you can't use that point. You can't use the point y equals 0. You can't use any point.
So there are no critical points.
Yeah, there are. Don't worry. That one's a freaky one. All right, guys. Let's take a look here. So for the first one, that's your fx. Fy is 6xy, right? Now, I noticed, please your God, you need two values for x, or a value for x, some values for y, that makes both of these 0 at the same time. The only values of x and y that make this one 0, so that's why I'm going to start here, because it's the easy one. The only things that work here, of course, are x equals 0 and y equals 0. You guys with me? So those are the only values I have right now that could possibly lead to something. So the reason I say it like this is I haven't done shit with this yet, but I've already got parts of the answer from this one guy. So up here, if x is 0, what could y be? So if I make x 0, how do I make that 0? If y is plus or minus 1. So 0 leads to, a 0x value leads to a 1y value or a negative 1y value. Those points, I constructed those points. They go together. I didn't just pick numbers off the page and throw them together. And I don't mean to say it like that, because as a student, you're like, I just got to get these stupid things together. But that 0 led to these values of y. Now, what does this 0 lead to? So if I make y 0, then of course I get the same thing again for x, right? Plus or minus 1. 1, negative 1. But there's no, for example, there's no 0, 0 critical point. Because 0, 0 would make fx negative 3. That's not 0. Do you guys kind of get the idea? You start with, you do both derivatives. You start with 1, and you make it equal 0, and then you use that information in the other one. Systems of equations. There are other ways to do this, but let's start there. What about the second guy? Let's see. So this one, I want to give you a nice easy one. What was it? 4x minus 4, right? And then fy was 3 minus 12y. All right. This is the one that leads to the confusion. Because then you start to say, I can just put these things together. No, it's because there's only values of x that make this 0. There's only values of y that make this 0. And that's when you can just start putting them all in all the various orders. Does that... So what makes this 0? 1. What makes this 0?
1/4.
1/4. That's your only critical point. It's the only point that makes them both 0 at the same time. I like it. Let's see, number 3. Oh, 3 hopefully was a quick one. Fx is the same thing, right? Fy will be what? I like it. So I like the way, there's a few different ways to look at this, but is there any way to make both of these equal 0 at the same time? So you could say, what are the answers to this one? When is this equal to 0? When y is, yeah, some kind of multiple of pi. 0, pi, negative pi, 2 pi, so forth. But this is only 0, but if I use any of these, if I use any k pi, become a pi. There you go. In here, it becomes plus or minus 1. It doesn't become 0. So is there any way to make both of these 0 at the same time? No. No critical points. The only critical points, the idea of a critical point is the points that make both of those partials 0 at the same time. So if you have time, you can just run through all of the points that you think are the critical points and make sure they individually make both of these 0 at the same time, right? So if that 0, 0 is a critical point here, 0, 0 does not make fx 0, so throw that one out. Okay, I like it. So here there's no critical points. And you saw that back in Math 180, if you think about it. Number 4, fx is what?
2x minus 4y.
Minus 4y. I love this one. Fy is
8y minus 4y.
oh, 8y minus 4x. So if you take one of them, if you set this equal to 0, you get y equals 1/2 x. Right, whatever way you did this, or x equals 2y. Same thing. Now, if you try to plug that back in, you might confuse yourself a little bit, but I want you to realize, if you plug this back in, you get 2x minus 4 times 1/2 x. And what is that? 2x minus 2x, 0. So for every single one of these, this is 0. And of course, hopefully you guys realize these are the same thing, just multiples of each other, right? So this is an example of a system of equations with infinite answers because they are dependent. It's a dependent system of equations. They lie on top of each other, right? So my answers will be every point that looks like that. Or if you have it like this, that'll work too. So there's a ridge. And we were talking over here, a really good example is the cylinder y equals x squared. And by the way, a cylinder could be the one we're used to, or it doesn't have to connect on one side. Right? So a cylinder is a little more general of a definition. But the cylinder y equals x squared has a ridge of minimums just running along the z-axis, right? So that's the simplest example of something that has this kind of thing happening. So somehow this is a ridge along this line that are all tied for maxes or mins. So you can think about parabola, that's the easiest way to think about that, running along forever. Are you guys with me? So that kind of thing can definitely happen. Yeah, okay, just did. All right. What about number 5? What's fx for number 5?
3 minus 2x minus.
I like it. And then what's fy?
3x minus x squared minus 2x.
I like it. Now there's a multitude of ways of doing stuff with this, but I think the easiest way, and I think a way that some of you guys caught on to, and you do the exact same thing. I want to make this clear. The math doesn't give a shit if you get numbers for x and y, or if you get expressions for x and y. It just says plug it into the other guy, see what happens. That's what the process says. So, of course, if I set this is equal to 0, I can take out a y. So either y is 0, or 3 minus 2x minus y is 0. So either y is 0 or y is 3 minus 2x. Cool. And then if you use that information in the other guy, if y is 0, what do you get from this guy? You guys still with me? Is that cool? Yeah, x is 0 or x is 3. So what points have I just done? This is a good idea. Right, the minute you finish out the other variable, write what points you've just created. So at the end, you're not just putting numbers together and praying. So here you get 0, 0, or 3, 0. Kick ass. What's happening? Or y equals 3 minus 2x, right? I really want you to understand, I'm doing the exact same thing I did earlier. I just happened to get numbers earlier, and I put one number into the other guy and got some points, put the other number in. So I put one number into the other guy and got some points. I'm putting the other collection of numbers into the other guy to get some points. So if y is 3 minus 2x, what does this become? And I want that to be 0. Let me stop there for a second. You guys, there's nothing different between this and that. It's just it took a little longer to write this. What's happening? Are you guys, I really desperately want you guys to realize, what things make fx 0? Y equals 0? Okay, shit, I better take that value and investigate the other dude. Or y equals 3 minus 2x. Okay, shit, I better take that and investigate the other dude. It's exactly the same process. Process don't give a shit. We give a shit. We're like, oh shit. It's just a lot of shit there, right? But now you just attack this thing. So you get, what do you get? 3x squared minus 3x? Yeah, x equals 0 or x equals 1. So what points did I just make? Now here's the thing. So when x is 0, what's this y? What points did I just make? 0, comma.
3 minus 2x.
When x is 0, this is 3. When x is 1, this is 1. So if you did it a different way, did anybody get more points than that? That wants to? Step up. What'd you get, Christian?
I got y equals 3.
Yeah, y equals 3. I got that. Here. X is 0, y is 3?
Yeah.
Okay.
Yes.
Alright. Do you guys start to see this? Do you guys start to see how this works?
So those are the two.
Well, careful. Here's 2 here, and there's 2 there. So it's a total of 4 critical points there. Now, trust me, if you just arbitrarily pick some random point and then do the second derivative test to it, the results could say almost anything. But the results are only valid if it's an actual critical point that you're plugging into it. Does that make sense? Okay. It's exactly the same as in Calc 1. What would the concavity be at that point there? What's the concavity at all points on this thing? Negative. So if I thought that was a critical point and I did the second derivative test, I would think that that was a maximum. I don't know if you guys remember this.
Yeah.
So if you take a critical point and plug it into the second derivative and it comes out negative, it must be a maximum. But why is this not the maximum? Because it wasn't a critical point in the first damn place. So the results of the test could be almost anything. They only mean something if you're actually using true critical points. I'm just saying this because in the homework, some of you guys got values for D and thought it meant something, but they weren't critical points you were plugging in there. So it didn't mean shit. All right, maybe. So don't think that it's the test is going to save your ass if you got too many critical points, because it's not going to say to you, hey, that's not a critical. It's just going to say, it's 6. And then you're like, oh, good, all right. Yeah.
So the second derivative test, is the test for concavity or the second derivative?
Yeah, the second derivative test that we use, notice how it's constructed from all these second derivatives, but since it's in another dimension included, it's going to be a little more involved, obviously, than the one we used back in Math 180, right? But it's the same idea. It's the concavity, but now it has to look at the concavity in all these different directions and the cross direction, the xy. So that's why it's got all those parts to it. Yeah, I like it. Oh, do we have... Where to leave off? One more, right? Yeah, I like that one, and I like that one a lot. Hint? Maybe. That could be a hint there.
Jeff?
Yes.
Quick question. How would you do the second derivative test on number 4, while you have expression? Would you just solve for it when you put it on the formula?
Oh, yeah. Oh, I love it. All right, good question. Real quick. This is fx, this is fy. What would fxx be? 2. What's fyy?
8.
It'd be 8. And what's fxy? Whatever way you look at it, yeah, negative fyx, fxy, it matches because it's nice functions, right? Do you see how the second derivatives don't depend at all on the, in this case, but even if they did, have like x's, you would just plug in this expression and you somehow would have to kind of like even out some way. You could try to think about what having a ridge of local mins or local maxes, what that would have to mean about concavities in certain directions. These kind of things. So this one's nice because these all came out to be independent of position. So it's got constant. So like the most easy example of a ridge of local minimums is a y equals x squared repeated. What's the concavity of y equals x squared? It's always positive, right? So the second derivative test would show me that it's a minimum for every single z value along the way. Is that cool? Okay, so yeah.
Is it possible? Would it be possible to have something that's like one of these, one of those parabola things, like that, and then, but somewhere, like at one of those points, it did this weird up thing so that it was a saddle point? Do you think that would be possible?
It would almost have to have some kind of a. It wouldn't be able to stay even and then suddenly do that. It'd almost have to have some kind of a slope to it to explain why it would do something different at some certain point. Does that make sense? So I don't think it could be even and then just right across and then do weird. Yeah, I like it. All right. That's it for that. Hopefully, did that help at all? Because I noticed when I was grading the homework and looking at some things, I'm like, okay, they need some help with this critical point stuff. I don't blame you at all because it's kind of weird, but it's just. At the same time, I didn't realize it was going to give us trouble, but now I see why. It's no vagueness. It's no just put everything together. It's one thing told me these. I put this in. I make these points. I put this in. I make these points. There's no ambiguity at all. There can't be.
We still have 6.
Oh, I still haven't done 6? Oh, that's right, because you asked me that question. All right, let's do 6. 6 is definitely a little freaky. 6 is a exercise in rewriting the original function before attacking it. Because the biggest mistake you guys are making was derivative mistakes. So one thing is you always rewrite radicals as powers, and you also throw anything on the bottom up if it's just a simple product. So I would write this as x to the 1/2, y to the negative 1/2. And then derivatives are easy. All right, what's fx?
1/2 x.
Cool. And what's fy? Negative 1/2. I like it. So this looks like, just to make it look a little bit, that looks like that, right? And then this looks like negative, what do you got, Jeff? Whatever, 2 square root of xy cubed.
No, the x is on the top.
Y to the, oh yeah, thank you. You can get it, Jeff. Square root of x over, then I can just write freaking y to the 3x. There you go. So, first thing is, what's not in the domain of the original function? We haven't had to worry about that yet, because the functions I gave you were nice, polynomial stuff, or trigonometric. Yeah, not be more specific.
Y,
No, x can be 0. X can be 0 all day.
Y can't be.
Y can't be 0.
They both can't be less.
Yeah, and of course they're both square roots, so you got that one. But that's the thing you really realize is that y can't be 0. So y can come from, gather. Y can come from 0 to infinity. X can come from 0 to infinity. All right, that becomes important. So what are the values that anything make this 0? No, because the only make fraction 0 is to make the top 0, and you can't make 1 0, no matter how hard you try. But what still is a value that I have to consider? I can't let y be 0. It's not in the domain of the root function. But can I let x be 0? Yes, because it makes this undefined. That's another place where critical points come from. Whereas the derivative, that's where you get stuff like this. Right? And that is still a maximum. Poor little dude. Just because he's at a cusp and he sounds like he belongs in dental school, it doesn't mean that he shouldn't be a thing. Or it's a kink and then it sounds like something else, but oh well. So here I get x is 0. Now if x is 0, what happens to fy?
It's going to be 0.
So what does x equals 0 do to fx? It makes it undefined. And what does x equals 0 do to fy? It makes it 0. So then x equals 0 is a critical component, right? So the critical points look like 0, comma, y, where y is greater than 0. Now that one I put at the end because that's obviously a little bit beyond, but still, I wanted to talk about it. If y equals 0, the original function is undefined, and that you just can't have happen. Do you guys understand from Math 180? Okay. Yeah, we're dealing with only real numbers. I want you guys to realize there's a whole other level of every math you've done that involves complex. It's called complex analysis. You could do integrals in the complex plane and shit like that. It's integrals you could never do now. You can totally do easily with complex plane kind of consideration. But anyway, go ahead.
How? I mean, the derivative is equal to 0. The fx is not equal to 0.
Come on now, guys. If I had back in calculus, if I had this function, what's the derivative?
1/3 x to the negative 2/3.
What's the critical points then? You can't make this 0, but you can make it undefined, right? So critical points are not just where the derivative is 0, it's also where it's undefined. Period. Yeah, exactly. So yeah, this is Calc 1. But yeah, so you get your critical points from making the function, the derivative, in this case partial derivative, 0 or where it's undefined. And there just weren't a lot of examples of functions, I don't think in the homework there were many at all, where it was undefined. So I want to give you at least one to look at.
And you like that one?
That's good to look at, but...
Okay.
So 4 and 5.
Thank you for the reminder.
Yeah, I'm trying. All right. But it's just good to see all the possible things that could happen and to realize your thought process is always the same. Look at one derivative, get the information from it, and then plug that one at a time into the other guy. Construct points that way. So I gave you a problem where there were no critical points before. That could totally happen. There's a problem where there were an infinite number of critical points. That could totally happen. And they could be defined in very strange ways. That can happen. Cool. Okay. So now let's open it wide up to whatever you guys want to talk about. Let me go ahead and give you guys the answer key for the practice test. There's one I didn't put on here we'll do together.
honestly, this could just happen.
So what was that? Oh, well, we were that.
I don't know. Probably a lab. It's like, oh, I actually got a reasonable amount, but then I was like, oh, I need an unreasonable quota.
3 is it? I don't know. It's custom enough for a reason.
What's today's day?
7.
What month?
Oh yeah, it was number 11 that I didn't do yet.
Experiment 16 to liberty property.
You need to take down.
Oh yeah.
Thank you.
Everybody's got a blank copy of the practice test, right? Does anybody need that blank copy practice test? Christian, what's up?
I was going to ask a question about this.
So hopefully I can.
First thing is you say, like, this is X, Y, Z.
Dang, we only have 3 labs left in this whole class.
No.
Can you believe that?
You're going to integrate. So we did an example. The very first example we did for double integrals was to find the area
There's 5.
enclosed in some curve, and then I showed you that it was actually math 180. We don't need a double integral for that because we just put a 1 inside.
Right.
So here I'm putting a 1 inside the triple integral. I don't have to look at this as being
We're here.
a 4-dimensional problem at all.
1, 2,
In a sense, it is.
4.
It's not really. So I can use triple integrals to find 3-dimensional
Volume of an area.
Yeah, because if I put a 1 inside.
Sure. So, and then this is, so you do set a
Because that is the function that is kind of like hovering over the xy plane. Now I could have solved for one of the other two and set this up in entirely different ways. But it's just easier to think of x, y as inputs because that's what we go into it.
That's not even part. Do you think you do?
Yeah.
This part you guys apparently all.
I don't trust anything that's written in the lab book. Because half the time people like, do this stuff that's not in the book. Don't do it.
Oh, Daniel, you're here.
Yeah, sorry.
Practice session. You got an answer, right?
Yep.
Is that you? I just get you guys mixed up. Can you give it? Okay. Is he here?
Oh yeah.
Where's he at? Oh, there he is. And what else do you need?
I don't know, do you have any new handouts today?
Well, you got the answer key for this, right? And we did this handout earlier today. Where did I put it?
We are getting this box on the
There it
test,
is.
right?
Yeah. We did this one early.
I hate you.
Oh, you okay?
It's the same as that.
Yeah, I didn't know if you both needed one. You got one? Okay.
Rough practice. Okay, oh yeah.
What's up?
I just
Oh, so guys, I want to do number 11 on the practice test. It's not on the answer key.
Wait, what? There is no number of that.
on the practice test?
Practice test.
On the answer key.
That's
Wait,
why I'm doing it.
oh.
Yeah.
Yeah, that's
Look at me being all nice and giving you square numbers. So, before we convert this to polar Can somebody tell me what the hell this means?
That means there's a circle.
Yeah. So the ribbon of area between these two circles. I like it. So the inner circle is a circle of radius 2. And the outer circle is a circle of radius 3. It's great. Yeah, so we're talking about this. So normally, if I had some, let's just do it over here for it to be different. And I go from an angle from here would be pi over 2 to whatever. So for every angle, I could then go from 0 out to this function, from 0 out to this function. So that's why the integral for r very often is 0 out to whatever the function is. Here, of course, I'm going to go from an r of 2 to 3. I like it. That's all. Nothing special about that. You're just not starting at the origin. So,
And then it'd be 0 to 0.
yeah. So now I can do. What does this become? RDR. I like it. RDR. So I'm going to drink some song. And then this becomes. I like it. And so R, like we said, goes from 2 to 3. As theta goes from 0 to 2. So that was not a horrible one. Most of the ones I don't think were too horrible in that section. Yeah. And the beautiful thing is, of course, if I'm not careful, I'll give you something that's impossible. But that beautiful little R dude